Listen, now one question was actually left to be solved because I just forgot that. Yeah. And this is probably the most difficult question because you people definitely don't know about the negation of quantifiers. Yeah, it comes under first order logic, so definitely you guys don't know about it. Many probably struggle in zeroth order logic, so I should not go into this. Yeah, I'm not your personal tutor or something. To be really honest, I'm just uploading the solutions so that I get some practice of my own mind to kind of repetitively get into these concepts again and again. Yeah, that was enough of arrogant words. Now I should just get on to the business. Basically, it is given that some sequence a n does not have limit. So this is that. Now this, if equality holds, then with the limit definition it has implication. If this is falsified, then this is also falsified. So the answer has to be the negation of limit definition. That's it. Do it yourself now. I'm just kidding. So what is the limit definition? For all epsilon positive, for there exists n belonging to this um, for all n greater than equal to n implies delta is less than epsilon, where delta is defined to be an minus deviation basically. Now think about it. This is the limit definition. Now one concept is there to be understood. This is the kind of universe in which the epsilon exists, R plus. This is the universe, the natural set for n. Similarly, the same universe is there for small n. So if we don't write them, it is all sufficient. If we write them, it is okay. And when we talk about the quantifiers, there are some conceptually, to be abstractly speaking, there is something called as the free variable or constraint variable. What I'm trying to say is, this is the condition A implies B, which is this inequality. So some things are being used here. Understand it this way: whatever new variable you introduce inside a quantified statement, it has to be constrained with the quantifiers before. If it is a free variable, then it is not first order logic, it is second order logic. When the abstracts, the universe is not defined, so it can fall either in the set or the negation of the set, which is the complementary part. So it is very complex, it is second order logic. So every quantity has to be abstractly defined in the quantifier set in some sense before taking the negation. So we have to take the negation, we have to write all the things which are basically a new variable of its own. Yeah. So what are the things that the delta is consisting of n? It is a function of n, and n is already defined with quantifier, so no need to do it. C is the value of limit, and C is not a function of n. C is not a function of n, so it has to be defined using the quantifier before the n plus b statement. You get it right? Epsilon is defined in this statement, so basically we write that epsilon, there exists, see now understand, we know by the definition of limit that C has to be a unique value. Even then we write there exists C. Why so? Because there exists means one or more than one. If it is exactly one, then also we write there exists C. There exists C for all epsilon positive, for all there exists capital N belonging to n, we can kind of combine the statements here for all n. And one thing, because to match the options, if we write like this, then this is a subset of n greater than equal to n, so this is also alright. This implies an minus c is less than epsilon. So basically now the negation of this quantified statement is what? It's this. You know this, right? Negation of there exists is for all, then whatever p if it's not. Similarly for that. So take negation of all. So for all c, there exists epsilon positive for all n belonging to this set. Then there exists small n, and then we say the negation of a implies b. Now we know that the original limit definition is false, so this is false. Its negation has to be true, and this is basically a naught union b not is true. So a intersection b not is true. So both of them have to be true. Only then this is true. So we can say that a implies not b is true, because then this whole is true, because these two are true. So now we can write it like this: n greater than n implies not of this. The delta is now greater than or equal to epsilon. We are taking the not. So if something is not less than, then it is greater than or equal to that. Where delta is again this deviation, and we can combine these two together. So finally the answer comes out to be this: for all c, there exists epsilon positive for all n belonging to n, there exists small n greater than n, implication the an minus c is greater than or equal to epsilon. So this is the answer here.